Okay, Assalamualaikum and good morning all. So this is the video of quantitative analysis subject LGB 20903. The title of the video is Integration of Variable Complex Function. Okay, I'm Madam Fauzia binti Abdul Rahman. I'm teaching a student in Bachelor of Marine Electrical Electronic Technology for semester September 2014. Okay, now look at to the definition of the complex variable integration. So complex definite integral are called complex line integrals denoted by FZ integration in curve C FZ dv. The integrand FZ is integrated over curve C. This is curve C. This curve C is a complex plane is called path of integration. This representation of C by parametric representation is Vt equal to xt plus I yt. Okay, we have properties of the definition. Okay, we have first we have linearity properties. Integration is a linear operation if the integrals of f1 and f2 over the path C exists. So does the integration of k1 f1 and k2 f2 over the same path. K1 and k2 is the constant. Okay, we can write it in the mathematical equation like this. Okay, we have k1 times f1z plus k2 times f2z dz integration dz. We can separate the coefficient and the addition itself. Okay, for example, this k1 outside the integration f1z dz plus k2 outside the integration f2z dz. Alright. The second property is sense reversal. Okay. Sense reversal in integration over the same path from z0 to z from the left and from z to z0 from the right. So we can rewrite it again like this. Okay. From z0 to z fz dz, we can write the wrong direction, but we have put negative here, so we call it sense reversal. Okay, so another property is path. Okay, if we have this, for example, this is curve C. Okay, this is curve C. Curve C, that's longer than there. Okay, this is curve C. Okay, so we can integrate from this part, so we call it C1 and plus with this path C2. Okay, so actually this is total zero. Then C1 and C2. Okay, so the calculation or the formula is this. Fz integration C Fz dz equal to integration curve C1 Fz dz plus integration curve C2 Fz dz. Okay, then definition for number 4 definition, we have let f a b is a complex number function. Okay, let fx equal to ux plus I dx for a for x greater than or equal a and x less than or equal b. Then the integration of fx from a to b can be rewritten like this. Okay. So ux dx from a to b integration plus I a to b integration vx dx. So we can separate real part and imaginary part, then we integrate. Okay. So that's the idea of the integration of a complex function. Okay, now look at to the exercise example 1. The example 1, we have to solve the integral of following function. Okay, so we have fx equal to x plus ix square. So we have to integrate this function. So from 1 to 2, right? So 1 to 2, we have fx dx. Okay, so from 1 1 to 2, we have x plus ix squared, right? Dx. So as I said before, we can separate it and then integrate it. Okay, so first we have x. So from 1 to 2, x dx. Okay, plus with I integrate from 1 to 2 x squared dx, right? Okay, so we can solve it by using the general idea or general formula for integration. So x, the integrate, we can get x squared over 2 from 1 to 2 plus I x power of 3 over 3, okay, from 1 to 2, right? Okay, then we can get this. So substitute 2 into the formula. So then we can get this. 2 times 2 power of 2, 4 over 2 minus with 1 over 2. Okay, the first part plus I, we can get 8 over 3. Okay, minus with the 1 over 3. Okay, then we can get 3 over 2 plus with the 7 over 3. So this is your final answer. And then we look at to example 2. We have to integrate cos 2x plus I sine 2x for this integral, for each interval. Okay, so we have to the interval equals 0 to pi over 4. Okay, cos 2x plus I sine 2x dx, right? So we can separate it. Okay, from 0 to pi over 4 cos 2x dx plus with the interval from 0 to pi over 4. This you have to put I here, sine 2x dx, right? Okay, so if you integrate sine, you can find, you integrate cos, you can find sine, right? Okay, so that we can get cos sine 2x over 2, differentiate 2x, then we can get 2. Okay, this is from 0 to pi over 4, right? And then plus with di. Okay, sine, integration of sine, we can get negative cos, right? Negative cos 2x over 2. Okay, this is from 0 to pi over 4, right? Okay, so we can out the negative 1 over 2 actually. 1 over 2, okay, so that we can get sine 2 times pi over 4, then we can get pi over 2, alright, pi over 2 minus minus sine, okay, minus sine cos sine 0, sine 0, okay, 0, this is 0, right? Okay, plus I, the negative cos pi over 2, so okay, over 2, right? Okay, minus with the negative cos 0 over cos 0, it's not over, cos 0 for I. Alright, so that we can get last final answer. We have 1 over 2 plus 1 over I. Alright, so this is your final solution. Okay, this is your exercise. You can try it at home, but I give you the hint of this particular question. Okay, we have this fx equal to e power of 2ix. Then the interval equal to 0 to pi over 4. So what we have to do is we have to convert this particular function to the trigonometric function. Trigonometric function. Okay, so you recall back how to solve this particular complex form to trigonometric function. Basically, r cos theta plus I sin theta. Okay, please recall back, and then you have to integrate. Terms by terms, right? Okay, so you can try it at home, and then please don't forget and don't shame to come to see me in my home.